Hello everyone, welcome back to our STR8CHEM session, and today's STR8CHEM, we're going to look at how to construct the most plausible Lewis structure for resonance structures. We're going to look at the example of CO3 2 minus, okay? So the first step is similar to what we have done before for the non-resonance structures, in which we need to find out what is the total number of valence electron involved in the formation of this species. So we have carbon and we have oxygen involved. And we want to find out the number of valence electrons. Carbon, if you look in the periodic table, it's in group 14. Therefore, the number of valence electrons is 4. Oxygen is in group 16 in the periodic table. Therefore, the valence electron that an oxygen has is 6. And when you look at the structure, you have 1 carbon atom involved, so that will bring you to 4. And we have 3 for oxygen, therefore that one is about 18. And you have 22, but if you look at here, you have -2 charge. So when you have -2 charge, you need to plus 2 there, okay? And thus the total valence electrons is about 24 valence electrons. So by showing this calculation, you will get 1 mark. So we know that there will be 24 valence electrons involved in the Lewis structure, the construction of Lewis structure for CO32 minus. Okay, so second steps. The second step is we are going to draw the Lewis dot symbol for oxygen and carbon, and we need to decide who will be the central atom. In this case, your central atom will be carbon, because carbon is more electropositive than oxygen. Remember, just now I said carbon is situated in group 14 on the periodic table, and then oxygen is on group 16 in the periodic table. Therefore, when you go across the periods, electronegativity increases. If you go back to chapter 3, and that means carbon will be more electropositive, and carbon will be the central atom, and oxygen will be the terminal atoms. Okay, so we do know that carbon has 4 valence electrons, so that is the Lewis dot symbol, and oxygen has 6, equally distributed like that. Okay, so when you count all of the valence electrons over here, okay, when you count the valence electrons over here, it is not the same as what you have in here, which is about 24. Okay, you get 24 right there. But if you look back over here, you have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So you have 2 electrons left that you need to put somewhere in here. Okay, so later on, we're going to be able to know where that 2 electrons will be. But for now, this is the Lewis dot symbol. Okay, so this is the Lewis dot symbol, and you get 1 mark for this Lewis dot symbol. Okay, so step 3 is when we try to construct the bonding pair, and as you can see in step 2, we only have lone pair. Okay, so that is your lone pair, lone pair, lone pair, lone pair, lone pair, and lone pair. And then what you have here, unpaired, 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 unpaired electron, unpaired, 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 unpaired electron, unpaired, and unpaired. So on this stage, step 2, you do not have any bonding pair yet, like what we have talked about for the non-resonance structures. So in step 3, we're going to try to draw the bonding pair. Oxygen just now, it's like oxygen, you have, carbon, and then followed by oxygen, oxygen, and oxygen. We do know that the oxygen atoms, they have 2 lone pairs each of them. And then they have this. Okay, I'm just gonna draw the lone pair here slightly. Okay, and then that is your carbon. So when unpaired meeting up unpaired, this unpaired with that unpaired, they are going to be forming a bonding pair. Okay, and then when you have this unpaired with that unpaired, that will form another bonding pair. Right, and then that unpaired with this unpaired, you're gonna form another bonding pair. We have how many unpaired? We have 1, 2, 3, 4, about 4 unpaired electrons. So this unpaired over here can form another bonding pair with that unpaired. You get another bonding pair right there. So we have no longer unpaired electrons on the carbon to form any bonding pair with the oxygen. But when you look at the oxygen, on the oxygen, you have 1 and 2 unpaired. So what's going to happen to that one? Remember, we have that 2 minus charge right over there. So what happened? We're going to add 1 additional electron, so that will be negative charge, and then we're going to add another electrons over there to make it, and then you're going to add negative charge. So when you count all the electrons, you've got 24. Okay, so when you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you have 24 valence electrons in total. So this is the Lewis structure for CO32 minus. But what about the formal charge? So let's look for the formal charge, yeah? So next, what we need to find out is step 4 is finding out the formal charge. Okay, so we're gonna draw that again. So we're gonna put okay. So we are gonna be doing like this. So the formal charge for carbon at CO32 minus. So carbon, if you look at carbon, the valence electron, okay, remember the formula, valence electron is 4 minus, when you look at the carbon, it does not have a lone pair, so 0, minus bonding pair, you have about 1, 2, 3, 4, 4 bonding pair at the carbon, so that one is 0 formal charge. So this carbon is 0 formal charge. So what about formal charge for oxygen? Okay, oxygen with double bond at CO32 minus. Okay, so that one is the valence electron for oxygen is 6 minus how many lone pairs? You have 1, 2, 3, 4, 4 electrons in the lone pair, minus you have 2 bonding pair on it, so you have 0 formal charge. So this is 0 formal charge. Okay, so what about the formal charge for oxygen with single bond at CO32 minus? Okay, so valence electrons 6 minus, you have 6 electrons for the lone pairs, minus 1 bonding pair, you have -1. Okay, so this is -1 and that one is -1. So that is the formal charge. Okay, so you will get 1 mark for this, 1 mark for that, 1 mark for this, and 1 mark for that one. So the resonance structures. Step 5, we're going to draw the resonance structures. Step 5, the resonances will be, okay, so the structure just now we have oxygen, double bond carbon, Okay, don't forget the formal charge. Over here, 0, 0, -1, -1. Okay. So for resonance, you need to show that arrow. Okay, that arrow is very important. And the second resonance would be oxygen, single bond, carbon. The double bond will changes places, will switches its places. So that one is 0 formal charge. This one is -1 formal charge. Okay, that one is 0. -1 formal charge. And then the third resonance for this is double bond will go right there. This is -1 formal charge, -1, 0, and 0. So that is how you're going to draw the resonances. So when you get all the resonances, you would get 1 mark, 1 mark, and another 1 mark for all three. Okay, so when you look at the resonance, it fits in the molecular formula over here. It has -2. Okay, you have 1, 2, -2, 1, 2, -2, 1, 2, -2 formal charge. So that's how you're gonna check whether you have got the right answers or not. Okay.